channel logging into Twitch.
Good evening, everybody. Welcome to tonight's edition of Shop Talk, hosted by the Triangle Area SQL Server Users Group. So with us tonight, it's a smaller cast than usual. Mala is currently living her best life in the wilderness, I believe. I think she was on some type of like Bear Grylls journey where she's got like a Bowie knife and a chuck of pemmican, and that's about it. Which, knowing Mala, actually, it's kind of funny thinking about. But nonetheless, we may see her back. She may be a little bit more grizzled, having wrestled a bear. But we'll see. We'll see. However, fresh from bear wrestling, Mike Christensen, who did, in fact, get the salmon, took it straight from the bear. So welcome in, Mike.
That's right. You got to be aggressive. They don't like weakness.
It's the way to do it. It's the way to do it. You gotta show the bar who's boss. And Anders in chat, I feel judged. Windows keeps telling me to clean up my desktop. You can only have 65,535 files on your desktop, Anders. You gotta eventually make another folder. So the general purpose of Shop Talk. I mean, the purpose of Shop Talk is really just to chat for a little bit and have some fun on a Monday evening. But the concept of Shop Talk is this is a chat-driven program. If you are in chat, which you probably are if you're watching this, otherwise you should come in and join us in chat. It's kind of fun. You have questions, we may or may not have answers. We probably have quippy remarks. If we're lacking both answers and quippy remarks, I don't know, you get your money back or something. 272 games. That's a fair number of games. I approve of that number. Although, now that Dredge just came out, I don't know, maybe it's going to be 273. Unless you've already got that one. But we've got a few things to talk about tonight. Not a huge agenda. I did have a larger agenda, but I got mugged by a giant rabbit. I don't know what was happening there. I don't understand the concept, why a giant rabbit would come after me, but also had a stopwatch and was very concerned about the time. I think it was the draft rabbit trying to check out my 40-yard time, but I'm not quite sure. This is all these days are blurring together. Mike, you looked like you were going to say something, and you just like, no, forget it. This is...
So something witty was there, and then it went real fast.
That will, just like the rabbit. That rabbit's going to get a third round grade at that rate. So, aside from draft jokes, we do actually have a couple of topics for the evening. Because, I mean, the draft's not for another 20 days. So, I mean, we got to come up with something else in the meantime. But, first topic of the night. And chat, if you have questions, if you have topics, throw them in. But first thing we're going to talk a little bit about actually was a direct message. I had a conversation with a fellow who listened to an episode that I was on for the SQL Data Partners podcast, in which we were talking about various clouds, and I made the flippant remark that you would have to pay me to care about GCP, which, by the way, is true. And so the person asked, "Hey, what do you mean by that? Is it that you hate GCP? What's the thought on it?" So I figured, hey, it sounds like a topic that will at least burn a few minutes on Shop Talk. So let's talk about how little I care about Google Cloud Platform. That's about how much I care about it. So, and that's the whole point of this. That, all right, I care about Azure because Microsoft gives me a whole bunch of Azure credits every year, and I get to play around in it for free and then get to teach stuff for free. Stop. Google has a cloud platform. Yeah, it's almost as big as Alibaba's cloud, but not nearly. And that's not even a joke. Alibaba's cloud is definitely bigger when you're outside the US. Next, you're going to tell me Oracle has a cloud. Let's not go crazy
They do.
here.
I get their emails. They do.
So Azure, yeah, I enjoy it. I get credits for it. I get to try it out for free. It's something that I can spend a lot of time in. AWS, have worked in it professionally, have learned from it professionally. I get it. it's also the largest cloud provider. So if you're going to learn how to use a particular cloud provider, those are some pretty good reasons. You're doing it for a job, you get free credits. It's one of the largest providers. For anything else, unless your job strategy is that you're a cross cloud developer or that you're an administrator who works in multiple clouds, or you're working at a company which uses some other cloud, if they use GCP or Alibaba's cloud or something else, yeah, okay, that's fine. I genuinely have no real problem with GCP as a concept, but at the same time, there's zero chance that I'm going to take time and effort to go learn it versus other things that I could be learning. The opportunity cost is just too high. You're not going to get enough of a market of companies that, oh, well, I live in GCP and thus you have to learn GCP in order to work with whatever I'm doing, to make that worthwhile, especially if you are in the SQL Server space. Yeah, there are some companies that are using it. And again, if that's what works, cool. But as a whole, yeah, that's probably the main thing I've got thinking about it is, okay, if you're going to pay me to learn it, then I'll learn it. If you're not going to pay me to learn it, I'll do something else. And that's kind of where I stand on there. And it would be similar if there were some fourth competitor, other than Alibaba and Azure and AWS. Oracle, if the Oracle Cloud, as soon as that takes off, I'm sure any year now, they'll finally have their third customer. But there's definitely diminishing returns. And also, when there are platforms like Terraform that go across cloud, there's less reason to really focus in on, I'm going to learn this particular cloud, unless it's one of the two big players, really. So market share, AWS 34%, Azure 21, GCP 11, Alibaba 5, everybody else about 3. Is that US based or global, Mike?
US based.
Okay. That sounds about right. So global, I believe AWS is a bit higher, Azure's a little higher, GCP is a good bit lower, Alibaba's higher. But that is 30, 50, 60. Now, also, that doesn't add up to 100, so there must be that may be percentages of companies that are using a cloud or something.
I'll double check the footprint here.
Okay, yeah, because if it's percentages of companies that are using a cloud, the number could add up to more than 100 because you have companies using AWS and Azure and Salesforce Cloud. I don't know.
Oh no, it does say worldwide. This is Statista.
So this is global statistics.
Yeah, that's what it says.
Okay. All right. Well, I guess my information about Alibaba was a little out of date, and that Google has cruised
As of
past
this is Q3 2022, so not too.
Okay. Yeah, that's close enough for us to talk about. And so, depending on what these numbers represent, there may or may not be something interesting in them. Notice how I'm hedging my bets really hard right now while Mike looks up what the source and everything is. But assuming that this is a reasonable breakdown of cloud market shares, because AWS should be a bit higher. They've historically been roughly half of the cloud market for the past several years, and they're usually about twice as big as Azure, and everybody else makes up kind of that last quarter. So we'll see what Mike has for the pie chart. But moral of the story, basically, if you work at a company that is using GCP, that's fine. And if I were working as a consultant for somebody who was working with GCP, then yeah, I'd have to learn about it at least enough to go along and do what I need to do. But unless somebody was explicitly paying me to learn about GCP, I'm not really going to learn anything about it. I'll know just enough about it to be able to fake it in a conversation, and otherwise say, well, I mean, I know how these cloud providers work. I know how Terraform works, so I can deploy assets across multiple clouds already. And anything that's GCP specific, you probably don't want to hire me to be the person doing your implementation unless you're actually paying me to learn how to use GCP as part of this implementation. So that's about what I wanted to go with in that story. And I think it's not just a GCP thing. It's true of a lot where you would have to pay me to learn about technology X, about technology Y. And I think that's a reasonable thing to stance to take in a lot of cases. There's no way we're going to know everything about everything. It is impossible. I wouldn't lose a lot of sleep not knowing GCP. Yeah, these bags under my eyes, none of that's caused by GCP. I'll tell you that much. And again, I'm not even making fun of Google Cloud Platform. I just don't even know enough about it to make fun of it. And this is a position of studied ignorance, I guess I could say, where I realize if I only have a certain number of hours per day to learn about things, that's not going to make the cut unless I have somebody saying, I will give you money to learn about this thing, in which case suddenly it makes the cut. It's funny how that works. Money's a good motivator to do a lot of things. That's why my wife pays me to take out the trash. So that's what I got on that topic. I want to go to the next topic, which is called draft flag driven development, and I'm gonna share a window here. Let's do this. There we go. That looks like the article. So this is an article that Mala mentioned in a couple weeks ago. We were going to talk about it in Shop Talk 2 weeks ago, but it turns out we actually had enough things to talk about. But with Mike having escaped, and it's definitely Mike's fault, not mine. There we go. With Mike having returned, wanted to talk a little bit about this article, and along the way, I want to get chat's feedback here because there's a part of this article that, I'm not even gonna share my thoughts on it. I'm gonna walk us through it, and want to hear what people have to say about it before I share too many of my own opinions. So Alex starts off the article talking about the importance of understanding that things break, even sturdy systems. If you make a bunch of changes to it as they change over time, you run risks of breaking things. And so no matter how much testing and verification goes into a change, surprises can happen when you have your thoroughly tested stuff that goes into production. So Alex's point then is, well, why are we doing all of our testing someplace outside of production and then shipping it to production saying that, everything looks good, everything's good to go? And brings up the idea, well, why not build where the system is going to run? So I'm going to walk through this with, again, no opinions. I'm going to try not to say anything snide, because in honesty, I don't like the argument. I guess I am giving an opinion. Screw it. I don't like the argument, but there's something that sticks in my craw is the thing. I just don't know what it is. I'm seeing these pieces in the argument that make me say, I don't want this. But I'm having trouble articulating it. And Marshall says, because while you're building, you can do some very, very bad things. And if you do that in your live systems, you're going to take them out while you're still trying to figure it out. That's a risk. And if it's data related, if you're writing bad information, there may be permanent consequences to it, especially if you're going to third-party systems. But so what Alex is arguing here is that it doesn't make perfect sense that as we're building something, we're also testing it step by step in the real world. Why wait to try it out at some later time and then discover that something got broken? How is that an agreeable, sensible approach? So his analogy is hiring some painters, and you have the painters who paint a wall in a test environment and then scrape off all the paint and then apply it to your environment, which I get that's an absurd example, but I also don't like that analogy because I think it's more like you're teaching somebody how to use a roller and they're applying the paint to a wall, and then you're saying, okay, now we're going to take you to the real house and you're going to apply the paint there. So I see it as more of the program is the painter, not the paint. Because your painter can be doing some very dumb things, which leads to poorly painted walls. So you want to figure that out on your test environment, on your block of wood that you're using to help train the painter before taking that painter and moving him to a house. And just having articulated that was, I think this is part of the problem that I have with the article. Actually, the analogy works because you get to evaluate how it looks in the test space to see if you like it. And if you don't like it, then you abort the process and move on to try something else differently. That part of the analogy, yes, it does work, I think, Marshall. But the analogy that he's got is that you take that paint and then scrape it off of the walls and somehow reapply it onto your new walls. Versus, you get a new bucket of paint and you have your painters paint the new walls in the color and style that you decided. So, okay, what would the alternative be? And or some hand-waving denials of my proposed remedy. So let's look at some real-life precedents. So, for example, look at how I'm creating this article right now. So he's talking about essentially when I write a blog post, I click the right button and I start typing. I don't have to go to a sandbox or an isolated environment where I can make changes, see the changes, and then eventually deploy those changes. And I kind of disagree again because there's a preview feature. Like you are writing in the sandbox. It's not live. You're typing it.
You wouldn't want if he had like 1,000 people that read his posts. He wouldn't want them reading it real time and like thinking through questions or like. I don't think, unless he was doing a demo on how to do writing.
Yeah, no, you're exactly right. I think you're exactly right, Mike. This is the thing that he's typing into is not the live system. It is in fact the sandbox. It is the editor for the live system, which is the front end website. So in chat, Solomon says, depends on the consequences of something going wrong. Is a mistake going to cost the customer or company money or worse? Because if you make a mistake on a message board, there may not be a lot of consequence, but stock trading or healthcare related systems, yeah, absolutely. What is the risk of something going wrong is certainly a factor in how cavalier you can be about analysis. So he does reference the draft node. Yeah, this is actually where we get to draft flag driven development. So basically he's writing these articles, he's saving them as drafts, and then when he's ready to go to production, pushes post. So at this point, I'm creating a draft. And it's a draft version of the product I will finally and hopefully release for public consumption. So while the article's in draft mode, only people with access to my Medium account can view it. And at a certain point, I decide I'm done. I hit the publish button, and it transfers to a resource that's available everywhere. So the beauty is that functionality, look and feel of the product is identical in draft mode as it is in publish mode, which means I get the point of publishing it. It's pretty much guaranteed that nothing unexpected will occur, and that publishing itself is a non-event. Which, yes, sort of. So new changes go into a dirty state that are tagged with a draft label, don't interfere with the live system. That way we can thoroughly test and verify dirty changes and simply flip to a publish flag. This is Nothing unexpected is quite an assumption. Yeah, that's true, Solomon. There's quite a bit that can go wrong between your WYSIWYG viewer and what goes out, especially if you think of, I've got some script that may actually accidentally be CSS, cross-site scripting. There are no guarantees when code path changes. Right. So even if you are thinking in terms of feature flags, yeah, there's still, even with feature flags, there's a lower risk, but there is still some risk to, I have a feature flag. The existence of the feature flag may itself cause a downstream problem. Like I implemented the feature flag incorrectly, or the path in code doesn't check the feature flag, or I have done something which was unexpected from the old code's behavior, or I've switched back and forth and my old code doesn't know how to handle the data generated from the new code. This argument trying to compare that to physical painting invalidates because of the difference in software duplication capabilities and consumption of physical material. Yes. I think, I don't know. I kind of like my argument that, because it's my argument. I do kind of like my argument that the thing that we're doing with software development isn't really the paint, the end product. It's the process of generating the end product, at least when it comes to business software. We're often not building the end product. We're not building the data or the report or the final analysis. We're building the process by which we can get to that final analysis. And at least unless you are building a report, in which case it's a different story. Maybe with that kind of a story, something like this works a little better. But the idea works there if you get to use something like containers and compartmentalize the changes from each other. But in a shared underlying database where both the draft and published versions interact with the same shared system, you have a lot more risk involved. Yeah, absolutely. To the point where I'm not sure you're really gaining anything from draft mode, things in a dirty state, because your dirty state can interfere with your clean state system, at which point your clean state becomes dirty as well. And then you're now having to try to undo whatever bad thing has happened. Yeah, you can say, cool, we'll revert back to the prior version of source control. That assumes there hasn't been any underlying problem where you accidentally, say, like Anders said, accidentally sent all their down payments to your account, or where you accidentally sold all of their shares because your code had a negative where a positive should have been. And yeah, sure, you can revert back to the prior code, but it's hard to undo those sorts of external transactions.
Yeah, I mean, I'm thinking even outside, just like basic stuff. I have a media server. I share one or two people, and like I wouldn't mess with it because somebody might be watching, Batman Returns or something. I don't know. Like I wouldn't want to mess it up.
That is true.
That's
People get
low
angry
stakes,
when
but I don't even want to try it. I don't want. I don't want to mess with it.
people get angry when you mess with a penguin.
I know, right?
Uh, Anders is laughing. Just use a version control system to roll it back. Last time I asked our devs for that, they looked at me like I had horns. That's it. Yeah. How do I revert back to this particular commit? I mean, I don't know. I was gonna make some snide remark about Git, but uh, it's possible. However, when you have complicated systems, okay, well, this particular commit of this system, if there's any sort of system overlap, which understandably in an ideal world you don't have, all your systems are independent, processing separately, everybody's happy. But if you do have a larger system that has multiple components in it, rolling back to a prior version may also break some other component because it was tested on the later version of the software. And so you end up with dependency chains where specific versions of dependencies end up possibly causing you more problems, where in some cases it's easier to roll forward instead of roll back. Essentially saying, all right, shut the thing off and then fix it, versus revert back to a prior version, just because the changes are so consequential. In a better world, those services are independent and aren't so tightly tied to specific versions that you would have this kind of a cascading issue. But I don't think we live in that world for the most part. In a lot of cases, we have systems that, oh, well, I'm expecting this code is out there because the code is out there. And if suddenly, that thing disappears, it needs to be reverted back to a prior version. We have issues. So I think there's a little bit of catharsis in this article here, because by talking it out with everyone, I think I figured out where my problem in it lies, and that it's ignoring some of the consequences of getting things wrong. And we do have separate test systems, because if a test system breaks, we don't have consequences. It doesn't mean, oh, my test system is done and then it just goes out to production and we never have to think about it. We never have to test it. Like Solomon said, yeah, anytime you change code paths, there can be things that break. You may have security concerns that are different between prod and a test environment. You may have user account differences. You might have differences in what information is available there, differences in databases, things that have changed between environments over time. And those sorts of complexities will cause problems. He is correct.
Well,
oh, go ahead, Mike.
I was going to say, yeah, more and more this seems like, in my head, it's a scale issue, right? Like if you're blogging and you have a gigabyte of text and something goes wrong, you can, in production, you can fix it. If you have a team of 2, 3, 4, 5, or you have a team of 20 and you have extra complexity, this reminds me of it just reminded me that I have a colleague or a friend who was a team leader for a software company, and I think that the owner's son was like on their team and had development rights and like pushed stuff to production or did something directly in production. It brought them down for like 12 hours. So like the consequences were massive in that context. In the context this person's talking about seems okay, but it's like, you wouldn't necessarily like do for a small thing that doesn't really impact stuff that's very non-complicated, like a website that just, I don't know, you type your name in and it gives you a fake last name. I don't know, like like a very uncomplicated product, or but as soon as all these complicating factors come in, it just seems like a really risky proposition.
Yeah, that makes sense. Marshall says he's correct in concerns that the test system can have just as many problems when it's not a valid analog to the live production systems. Sure, if your test environment is not reflective of production, then your test environment is not necessarily providing a lot of value. So you may be confirming that some behavior happens in this environment, but if that's not what really happens in production, then you're not really gaining a lot of new information. So Solomon says, small difference between code paths, meaning going from draft mode to live mode. Also, once the main code changes are in prod, even if not fully live due to draft mode, you might still have altered existing code to accommodate changes. That is still a risk. Certainly. And that was where I mentioned, like with feature flags, where, hey, I flipped this flag on, and in an ideal world, all of the rest of the code that doesn't care about the feature flag, nothing changed. And the code that cares about the feature flag has relevant changes. But if you have a problem, if you've accidentally messed up some bit of the code based on that feature flag, even turning it off, you may still have the new code that expect some result from that feature flag. And so you may have put yourself into a state where some information is bad, or you're in a failure state. So this approach doesn't seem that well thought out or mature, but interesting thought experiment. I would agree. I have no problem with people throwing out ideas, and this was one that met the threshold of interesting enough to talk about, but I had problems with it. I just, until we actually talked this through today, didn't really, couldn't articulate it very well. I just knew in the back of my mind I did not like this. And it wasn't just because I'm a stodgy person who hates anything new. This is also true, but it was not the reason in this case. Speaking of stodgy people who hate everything new, let me talk about how much I like ordered column store indexes in SQL Server 2022. So Ed Pollock has an article, and by the way, let me give you the link to the first post, and then I'm also going to give you the one to this Ed Pollock article, Redgate article from Friday. There we go. Both of those are in chat right now. And so Ed has this essay on what's new with column store indexes in 2022, and specifically the order clause when you're rebuilding a clustered column store index. This is something that has been available in a dedicated SQL pool in Azure Synapse Analytics, and now it's available on premises in SQL Server 2022. One important thing, as Ed notes, data order is not enforced by a SQL Server process, which means that even though you've created an ordered clustered column store index, it may not actually be ordered or fully ordered. And in that regard, we still have to manage the data. So you can automatically sort as part of an insert or rebuild process. And this is the walkthrough of how you would do that. So again, this is clustered column store indexes. The non-clustered column store indexes don't have an order by clause associated with them. In this case, Ed has created a big old fact table, created 7 million or so records in this big old fact table, which is a reasonable number, and has created a clustered column store index on said big old fact table. So in this case, this syntax is just creating the cluster column store index, no ordering. If you look in the column store index, where is it? Column store segments, DMV, then we can see the breakdown of the different segments, how this table, this partition, this clustered column store index, here are the segments for it. And the row counts, the first one is a fully packed row, which is 1,024 times 1,024, or 1,048,576. And the rest of these are close to fully packed, but not totally. Now, these are unordered, which means that what records are in one of these particular segments, we don't know. And we would have to search through each segment if we're looking where some number is greater than 10. So in this example, like if I say, what's the sum of total excluding tax from this fact order where the date is December 4th? In order to do this, we have to read 1,540 lob logical reads. So we're having to essentially read the entire clustered column store index to find the records that are associated with that particular order date and get the summation. 8 segments were read, 0 segments were skipped. And by contrast, if we drop the existing one and add a new cluster column store index with drop existing on max stop 1, then we rebuild, and it looks like fact order big CCI, order date key. I see. So okay, he's created a clustered index, not a column store index, clustered index on order date key, column store index just on the general table, and we have records again packed. In this case, 6 of the 7 groups are packed fully. One of them is not fully packed. And we perform another search on order date because there's a clustered index that is using order date key. When querying this fact order big CCI, we can ignore some of the segments. So only one segment was read, 6 segments were skipped. We only had about 300 logical reads. We did have some read ahead. And end result, better performance. So Ed has some commonly what we see is structure to accept insert and delete operations, not wanting to do any updates, which is generally the case with column store indexes. Any updates mark a row as ready to go, ready for deletion, essentially. You give it a tombstone marking. Basically, column store index updates are really insert a new record and then eventually delete the old record. That deletion happens on an index rebuild, not even a reorganize. And insert data at the end of the table for the most recent date dimension. So I guess that would be most relevant date dimension. If a large table needs to be converted to column store index, then you may need some trickery. First, you order it, then you rebuild with this column store index so that all the data is already sorted by order date key when you rebuild it. However, this is where Ed mentions, hey, we can now add the order clause in the create clustered column store index and say order it on the order date key. And that way, you don't have to have the data pre-sorted for this to work. And so Ed goes through a lot of what you would have to do, what some of the consequences are, what happens if you don't have enough disk space in TempDB, that sort of thing. One quick note is this is an offline operation. So if you are trying to rebuild a clustered column store index with ordering, that's not something you can do online. You are going to block during that time. And usually these clustered column store indexes are big tables that tend to be pretty frequently used, which means taking them offline, even for 5 minutes, can be painful. So that would be something to think about. Now, in a partition table, the operation is offline for the relevant partitions. So if you're rebuilding one partition at a time, then for most of the partitions, because people don't usually access older data, the weights may be a lot more okay. But at the same time, you probably wouldn't need to rebuild that as much, assuming that this is older data that is stable. So that's kind of a little bit of a trade-off there. But nonetheless, in performing this, we see it takes a little bit of time for the clustered column store index to build. Along the way, there is a sort operation when inserting into the fact table. So new syntax above with the order by statement does include a sort, which is going to slow things down a bit. And SQL Server needs to sort the entire data set in order to create the index, which may be a problem. So notes and considerations down here. Only cluster column store indexes can use the order clause. As I mentioned, non-clustered can't do that. Ed notes that they inherit data order from the row store index structure. So whatever your clustered index is on your row store table. Order column store indexes have some problems. Rebuilding is an offline operation. Sorting has to be done in TempDB. And if sorts spill the disk, then the sort is aborted and data order may not be perfect. It won't fail everything. It'll just be like, I couldn't finish sorting. Here's your column store index. So ways to get around it: do this per partition. If you do need to sort in tempdb, make sure you've got enough space allocated. If you have an enormous column store table, you're going to need a fair amount of tempdb for the operation. As Ed mentions, you have a 500 gig column store index that's being rebuilt. You'll need at least 500 gigs of tempdb space to do that building. And sort operations, make sure that they are able to complete in their entirety, which means you're not going to be able to spill over with the sort. So if you exceed the memory grant, then the sort operation just marks as, I got as far as I could, and then I was done. So we can get an example of what that looks like when you do have spillover. Effectively, it's very similar to you just don't have an order by clause on your column store index. Also, just because you have an ordered column store index actually doesn't mean that querying the column store index will automatically order things for you. That is something to keep in mind. You're still, if you care about the final order in your result set, you will always need an order by clause. Similarly to, hey, I used a clustered index and I have this column as the clustering key. That doesn't mean that your data is always going to come back in that form. It may come back sorted by the clustered index. It may not come back sorted by the clustered index. The only way you can guarantee it is with an order by clause. But what this can do is help in terms of partition elimination, segment elimination, I should say, for the column store index. So if you're commonly filtering, commonly querying by a certain date value or a certain numeric value, then you could have the order by clause on your column store index by that value and possibly take advantage of segment elimination, which will probably make your queries come back faster. Should involve less I/O, may involve less CPU. So as a whole, this is not a 3-star article. This is at least a 4.8-star article. So that person who gave it a 1 star, I give that person a 1 star. I give Ed 4.8 stars. What do you think on that, Mike?
I think that I was trying to remember in my head, like the segment is like a certain amount of pages.
You're thinking an extent. One extent is 8 pages.
Okay, so yeah, I was like, I need to walk through that one. I have not used column store indexes very often.
Yeah, so the general idea of column store indexes, to give the 30,000 foot elevator pitch, which is a really tall elevator, the idea is I'm going to take this data and I'm going to store it in columnar fashion. I'm going to store it by column as opposed to by row so that I can compact the data down really well. And part of this compaction is that you have to break the data into segments. A segment is allowed to be 1,024 times 1,024 rows at the most. So that's the 1,048,576 or thereabout rows. If you have that many rows in a segment, that means it's fully packed. You cannot fit a singular row in there more. If you have less than that number, it's not fully packed, but it may still be good. 800,000, 900,000 rows, no big deal. 200,000 rows, I could be packing this in better and have fewer segments, which leads to less data stored on disk. Think of it like internal fragmentation in the old Windows hard disk days, where all your data was spread out along the disk and you wanted to defrag it and have each sector of data aligned appropriately so that the spinning head could hit those spots more efficiently. Kind of like that. conceptually totally different from that in practice. So it's okay, Solomon. You don't have to explain how I'm wrong in the
Little,
analogy. I understand it's not the right analogy, but I'm rolling with it anyhow. I go in with the analogies I have, not the analogies I wish I had. So basically, with this column store index, I want to be able to pack as many rows into a segment as possible. If I have 20 million rows and I'm able to pack that into 20 segments, each segment is going to be a certain number of reads from disk. It's going to be a certain amount of compute operations. So if I only have 20 segments to go through, then it's going to be less intensive resource wise than if I have 100 segments that I have to go through. And that's because there is a cost to reading data from a segment. So it's similar to pages on disk in that way, where if I have 20 pages to read 10,000 rows, it's going to be more efficient than if I have 200 pages to read 10,000 rows. If it's the same amount of data overall and we just have a lot of on-page fragmentation. So those segments are just how we split out the data for columns in our column store index. And that's different from partitions on a table. That's a slightly different story. But yeah, so these segments, if we can find a way to reduce the number of segments that we're reading, well, that's even better for us. Similar to if I go from 10 segments to 5 segments, I cut down I/O. Well, if I go from 10 segments to 1 segment, I cut down I/O. And that's where you could potentially get a benefit from an ordered column store index. If my access path is almost always on this filter column, then I may be able to narrow down the number of segments that I need very early on, only come back with 1 or 2 segments, and now my queries operate a little bit faster.
and then, of course, this is a long article with good examples, but is it easy? So some of the things that make factor into like whether it's worth it being offline using tempdb and knowing how much memory you have before you spill over to disk, are those things all very easily surmountable for like database administrators, or is it like is the juice worth the squeeze? You know what I'm saying?
Yeah, I get what you're saying. Unfortunately, the answer will be it depends. So offline, whether the index can be offline for a rebuild, that's going to depend on access patterns. Like I mentioned, this is most commonly used in warehouses. It's fact tables, very large fact tables, a lot of numeric columns, no or very few string columns, and so the intent was, let's optimize for fact tables. Well, if your fact table is used 24/7 and you don't really have a window for I can take this offline for 10 minutes, then yeah, you're going to have a problem. If you're using a warehouse that's in use 12 to 14 hours a day, but there's a period overnight where there's very little or no usage of it, not a big deal. As your table gets larger, if you're talking trillions of rows, it may take 20, 30, 40 minutes for that rebuild to complete. If you're talking about 30 million rows, it may only take 12 seconds. 12 seconds, I can fake 12 seconds as, oh, you must have had a network blip. Like if you can comfortably blame the network for a problem and people would reasonably believe you for it, that is, I think, a reasonable amount of downtime. It's when you can no longer blame the network. Like if it's down for 2 minutes, that's not you had a network blip. That's you had a problem. But if you can credibly assert that the person's internet connection is flaky, and they're willing to believe it, that's my general criterion for your downtime is okay. Or if there's nobody there, if this is like the tree falling in the woods, if there's nobody there to experience the downtime, did it really happen? So yeah, for downtime, that will be a factor. If you have a very busy, constantly accessed server, probably going to be really tough. And that was an issue early on with clustered column store indexes, where in 2014 you could not rebuild them online. In 2016 they allowed rebuilding online. So I'd used column store indexes in 2014 and couldn't actually rebuild the things, and so performance was worse than it should have been. But because we couldn't take the time to rebuild them, when 2016 came out, I was like, oh, I can finally rebuild this thing online, and there's a very small wait versus possibly several minutes. Ander says, so basically useless in OLTP. Mostly useless, yes. Column store indexes are definitely an analytical solution. They are certainly a part of Microsoft's push for OLAP and HTAP, where HTAP is hybrid transactional and analytical processing. So it can be useful in OLTP solutions where you have an extreme number of writes and relatively few reads, but it has to be the right kind of data that you're writing, and the reads have to be the right kind of reads. If you're doing single record lookups, no, don't use column store indexes for single record lookups. Those are really bad. But if you're doing aggregations, if you're doing processes across millions of rows, yeah, column store indexes are designed to optimize those types of queries. So for the most part, if you're doing a lot of that in your OLTP system, then either you don't really have an OLTP system, or your OLTP system is hopefully HTAP and more likely just a mishmash of transactional and analytical processing, as opposed to cleverly designed to do certain operations. If you have that mishmash, you're probably not going to gain a lot from clustered column store indexes, unless you have tables that are primarily read-based and aggregated read-based, ideally with bulk inserts. And Anders and I both had to deal with some table problems where column store indexes with trickle loading was a real problem in SQL Server, especially as 2016 and 2017. I think it might have been fixed with SQL Server 2017, but I know in SQL Server 2016 there was a problem where if you did onesie, twosie, or dozens of rows inserts into a column store index, a clustered column store index, it would just create a whole bunch of row groups. And so we'd end up with tens of thousands of row groups, these segments that I was talking about, and each row group might have 500 rows in it. So instead of packing everything together in a nice million row block, we have 5,000 row groups, each of which has 20 rows. And you could imagine that the performance of that would be a lot worse, because you're having to go grab each row group. You're not getting the advantage of compression in terms of, hey, these values are roughly the same. I can perform column store compression and shave this down from 30 megabytes to 2 megabytes because I have a lot of repetition of the same values in my column. So couldn't do that nearly as much, and accessing them was a bit slower. You had to unpack and analyze each row group separately. So that kind of trickle loading was a major issue in 2016. I believe it has been fixed, but even so, my permanent fix for it is don't trickle load. Trickle load into a transactional table and then bulk insert into the column store index once you have at least a minimum number of rows, like 200,000 to 1 million rows. But all in all, even with those caveats, even with some of the caveats on ordered column store indexes, column store indexes are still a great performance feature for analytical queries in SQL Server. They're a huge amount of space savings. So you have significantly less I/O. I/O tends to be the slow point for most systems, and the query responses when you're doing aggregates, which is usually what you do in a warehouse, response times are considerably faster. You might be talking upwards of an order of magnitude faster than equivalent row store queries, possibly more than an order of magnitude faster. But also, we're not talking point lookups. I'm not saying like, give me this record where ID equals 192.605.406. Column store indexes will be really bad for that.
Mm-hmm.
But if you have that kind of situation, you can have a clustered column store index and then non-clustered indexes on top of that. So if you do have, most of the time you're querying this in an analytical fashion, but every once in a while I just need to grab a single row, then you can have the non-clustered column store index. In practice, what that means is that your table space might take up 1 gigabyte of data, and then your index space might be 30 gigabytes of data, where your single index is considerably larger than your column store index, which stores all your data, simply because the column store index is so good at compression, and your row store index, even with page level compression, is not. But that's the elevator pitch. Fortunately, it was a really long elevator. Probably one of those really slow ones where it takes forever to go from floor to floor.
At a hospital, like they go real slow. In
Yeah,
hospitals.
exactly. Yeah, hospital
Don't
elevator
wanna,
versus
don't want
a
to shake up
casino
your
elevator.
organs.
Now we're all breathlessly waiting. What's Mike going to look up?
Using parameterized queries in batch operations. Lesson 2.
Well, I think we're gonna save that for another day. We'll learn all about parameterized queries some other time, because for now we are pretty close to the top of the hour, and I think I'm gonna call it, folks. So good to see everyone in chat. Hopefully you had a good Easter, good Pesach. That when Orthodox Easter finally rolls around, everything's good. And a good draft, I guess. We'll see each other again before the draft, maybe before Orthodox Easter. Actually, I don't know when Orthodox Easter is this year. See you all next Tuesday. Yeah, Anders will be in person next Tuesday. He's going to be at Tech Systems. I was going to say we're going to be at Tech Systems, but I'll actually be in Redmond at that point. But if you're in town, Raleigh, Durham, Chapel Hill area, come check us out. It's at meetup.com/trypass. This will be an in-person meeting, in-person only. Starting next month, the main meetings will be hybrid, in-person and online. But this month, we won't have the equipment available for that, so it's going to be in-person only. You can only see Anders in person. And if that's not reason enough to go, I don't know what is. So meetup.com/trypass to sign up for that one. And there may even be pizza. It's been 3 years, so we may be a little rusty on this whole feeding people thing, but we'll give it a go. Regardless, and you can talk bad about me. Yes. Yeah, I mean, that's probably the best reason to go to those meetings, is so that you can sass talk me. Especially when I'm not there, but even more especially when I am there. So with that, we're going to wrap things up for this evening. Note that tomorrow we have Brian Carrick. People may remember Brian Carrick. He's now a big Microsoft PM, living the crazy life in Redmond. He will be talking to us. So sign up for that. Meetup.com/trypass. That's going to be next week, 6 p.m. Eastern time. It's going to be about SQL Server storage from A to Z, or possibly Z. So with that, let's wrap up for the evening. Everybody, until we see each other again, take care.
Bye.